What is neurodevelopment? When you think of a label, whether it's ADD or ADHD, you're thinking of symptoms. Rather, you want to look to the root cause, and one of the main root causes is the brain. Garrett had a lot, we don't know specifically what caused Garrett's concerns. We think that there was some vaccination damage, he was severely oxygen deprived at birth. I had a very serious viral infection when I was 4 weeks pregnant with Garrett. There may have been a little bit of genetic tendency, we don't know, some sensory stuff down the road that kind of, in previous generations, that maybe popped up from Garrett. And this is what slowed Garrett's, what we call neurological organization or development. Typically, at birth, your little baby is interacting with his environment. He is feeling with his skin, he's seeing a little bit with his eyes, so his auditory system is bringing in stimulation information. It's that interaction that happens out there, that interaction with the brain, that actually develops you, that actually brings you up to what we call neurological organization. And that happens from birth to about 7 years of age to about 2nd grade. We saw, well, now we believe, and we know actually, that in utero there are developmental stages of the baby goes through. We believe, initially we started looking at a child developmentally from birth on, but we know that there are things like primitive reflexes that need to occur in utero that organize the baby's brain. I believe that because of the viral insult, and I actually had a rubella vaccine 3 months prior to getting pregnant with Garrett. And if you know about rubella, it can cause neurological damage. And I was one of these women that I was very compliant with the doctor. I did not get pregnant. I was told not to get pregnant until 3 months. And then it was safe to try. And I got pregnant 3 months and 1 day after that time. I really think that kind of started the whole stage for Garrett. And the environment just could not provide enough organization, enough stimulation for him to achieve what the brain needed to achieve in order for him to be able to hear properly, see properly, feel properly. Like, he would cinch his belt so tightly across his waist because he couldn't stand. There's a reflex that was right across the lower back. He could not stand anything touching that little reflex there. And it's called the spinal column reflex. And if you run your finger down the side of the back, on either side of the spine, do one side at a time. If the hips sway one way or the other, that means the spinal column reflex has not been pushed down or integrated. And that's a reflex that actually helps the baby corkscrew through the birth canal, and once the baby's born, developmental stuff happens, and the interaction with the environment pushes that reflex down. For Garrett, it didn't, and he was a bedwetter until he was about 13 and got that spinal column reflex pushed down. So it's all about organizing the brain. And again, the brain's a phenomenal piece of creation. The plasticity and redundancy of the brain is incredible. The plasticity means it's not hardwired. It's not a hard drive that you can't change. It is changeable and moldable at any age. And if they have told you, if your child hasn't talked by 5 years, they're not going to talk, forget it, that's not true. I've worked with adults who have not spoken a word who have started speaking. So it is possible by stimulating this magnificent piece of creation. You can either halt progress through deprivation, or you can accelerate the progress of the central nervous system in the brain through proper stimulation. The potential of an individual is definitely determined by the opportunities presented to them, and we certainly hope to give you some good opportunities tonight to go home and work with your children. So we want to unlock the child's fullest potential, fullest learning potential, fullest potential for function in overall life in every area through talking and utilizing the neurodevelopmental approach. Okay, what is neurodevelopment? The neurodevelopmental approach, the way we view it as ICANN neurodevelopmentalists, started about 6 decades ago in the early 1940s with the work of Glenn Doman, Carl Delicato, Dr. Temple Fay, who was a renowned neurosurgeon. So there was a physiatrist there was a neurosurgeon, there was a special ed person, RNs, and several other people involved in this work. So this is not like new work. This is not like the flavor of the month kind of thing. This has been evolving, changing, becoming better and better over time. And Linda and I and all the other neurodevelopmentalists with ICANN are constantly learning. It's not something where you reach a level and then that's it, you never learn anything else. We are always searching out better approaches to helping our children. The neurodevelopmental approach, like Linda said, works with something called neuroplasticity. At birth, a baby is actually functioning right here. The spinal cord and the early part of the brainstem. Actually, a newborn baby is just like a step above being comatose. Not a lot of function. There's reflexes, the sucking reflex, the startle reflex, the Babinski reflex on the foot where you touch the foot and the foot splays out. Pupillary reflex is nothing very elaborate. It's all involuntary, and it's all meant for survival. Now, a baby is born with all the brain cells he will ever have in his life. In fact, the brain cells start dying during the birthing process. There's some assault to the brain. So right from that time on, our brain cells are dying. Now, if you look at a baby's head and our heads, you'll notice quite a difference in size. That's not because the baby has fewer brain cells than an adult. It's because the baby has very few what we call neural connections between the brain cells. At the brainstem, when the baby is born, there's only the pathways at the lower level. And it's those pathways that allow us to function. It's like, let's say if you have let's think back to a decade, I don't know, maybe dating. Yeah, probably about a decade ago, when we didn't have cell phones and satellites. The phones were connected by telephone poles. Let's say the phone, we have two phones. Each phone represents a brain cell. If you don't have a wire connecting them, you can't communicate, right? You can't tell your neighbor, oh, can you get over to this, when you go to the store, can you pick me up some milk? I'm sick with the flu, can you drop it off at my house? I really appreciate it. If we look at the brain, the pathways between the two brain cells is that telephone wire. It allows communication. The other parts of the brain, where everything from the brainstem up, has no pathways at birth. That's why that baby isn't born with the ability to learn algebra, because that part of the brain hasn't developed pathways to communicate. The job of the baby is to interact with his environment to allow stimulation to develop those brain cells. Every time, like a newborn baby, you shine a light in his eye, the pupil constricts. You take the light away, the pupil dilates. That's the first level of development. Every time the light goes on, off, you're working that part of the brain and setting up growth of pathways. Once that's efficient, it kind of kickstarts the brain into the next level, and on it goes. We know that it's the interaction between the environment and the baby's, particularly the brain, but the sensory organs bringing information that develops the brain. We also know that this development occurs from birth to about 7 years of age, and once a child reaches 7, if those developmental pieces, or what we call milestones, have not been established, the chances of it happening through what we call random interaction with the environment is pretty close to nil. So if you have a child who cannot speak because he hasn't developed all those pieces of the neurological organization by the time he's 7, he's likely, without intervention, not going to speak when he's 20 or 25. It's not going to happen. But we know through much devotion and studying of babies developing that we can actually simulate that random stimulation to go back and target those specific developmental pieces. And that's why we can help children to learn to speak who've never spoken, who can learn to perceive sensory information appropriately, who can go on to read well, who do not, who are no longer impulsive or lack concentration.